120 conduction mode. That is 180 conduction mode. Next we will see 120. The circuit diagram will be certainly remain same. There is no change at all in the circuit diagram. Only the conduction will change. There 3 switches are conducting at a time. Here only 2 switches will be conducting at a time. Okay. So one switch will conduct for a duration of 120 degree. So what about the next 60 degree? Nobody is conducting for next 60 degree. You will get 0 voltage for 60 degree duration. For a particular cycle, you will get 0 voltage. Okay. So one switch which is conducting for 120, 2 switch will conduct at any instant of time. Okay. So the conduction sequence is certainly 6 1, 1 2, 2 3, 3 4, 4 5, 5 6 and 6 1. So it is repeating thereafter. So mode 1. So when 6 and 1 is conducting, how the circuit will be? 6 1. Where is 6? This is, yes, this is 6 and this is 1. So when 6 is conducting, B is connected to the negative, and when 1 is conducting, A is connected to the positive, right? B is connected to negative, A is connected to positive. So it's found to be a very simple circuit. Okay, so this is the equivalent diagram now. Okay, when 6 and 1 is conducting, so again we have taken a balance load, R and R, both are same. So what is the current flowing now in this case? So both are in series, so Vs by 2R. The current is flowing Vs by 2R. Okay, so now we can calculate the phase voltages. What is AN? We can calculate the phase voltage. We can go from neutral to the phase. Okay, so this is plus, this is minus. We are going from negative to positive, so it will be plus. Yes, yes or no? It will be plus. So plus R into the current flowing I. So what is I? Vs by 2R. So RR will be cancelled. We will get Vs by 2. Okay. Next, VBN. What is VBN? We are going from negative, sorry, plus to minus now. We will go from neutral to phase. So this is plus, this is minus. Current entering we have taken plus, current leaving we have taken minus. So plus to minus we will get minus. So it is minus R into I. So minus Vs by 2. Minus Vs by 2. So VCN, there is no presence of phase C here. Okay. So we will not get any voltage in phase C since no thyristor or no switches are conducting which refer to phase C. So we will get how much? 0. VCN will be 0 at mode 1. Okay. Similarly, we can find out VAB. What is VAB? AN minus BN. Okay. How much is AN? Vs by 2. How much is BN? Minus Vs by 2. Okay. So it will be 2 Vs by 2. So it is getting Vs. Okay. So minus Vs by 2, minus of minus, so plus Vs by 2 plus Vs by 2, 2 Vs by 2 will get how much? Vs. Okay. Similarly, VBC, we can find out VBN minus VCN. Okay. So minus Vs by 2 minus 0, you will get minus Vs by 2. Okay. Similarly, VCA, so 0 minus Vs by 2, so we will get minus Vs by 2. So what happens in mode 2? 1 and 2 is conducting. So where is 1? This is 1. So A is connected to the positive, 2 is conducting. So this is my 2. So C is connected to the negative. Okay. Okay. So this is the equivalent diagram during mode 1, mode 2. This is the equivalent diagram. So this A is connected to the positive and C is connected to the negative. Okay. So how we will get now? What is the current value? Current value will remain same. So AN and CN we will get, BN will be 0. Okay. AN will be R into I. Okay. So Vs by 2. BN will be 0 and CN will be minus Vs by 2. Okay. Similarly, we can find out AB. AN minus BN. So Vs by 2 minus 0 Vs by 2. Okay. Then BC Vs by 2, and similarly CA minus Vs. Okay. Next, mode 3. So what are conducting here? 2 and 3. So we will see. So this is 2. So 2 and 3 means C is connected to the negative, and 3 means this one. So B is connected to the positive. So B and C are conducting here. That means A will be 0. Okay. Phase A is not conducting. So what is the voltage in phase A? It will be remain 0. Okay. AN with respect to neutral, it will be 0. Okay. So this is the circuit diagram. AN is equal to 0, BN is equal to Vs by 2, okay, and Cn is equal to minus Vs by 2. Okay. Similarly, we can find out line voltages AB, AN minus BN. So minus Vs by 2, BC, Vs, and Ca minus Vs by 2. Okay. So mode 4, 3, 4. When 3, 4 is conducting, S3 is here, so B is connected to the positive, and 4 is conducting, S4 is here, so A is connected to the negative. So A and B will be there, so A and Bn, Cn will be going to 0. Okay. A and Bn is there, Cn will be going to 0. So this is plus, this is minus, so we are going from negative to positive, so we will get Bn positive, whereas An is positive to negative, An will be minus Vs by 2, and this is plus Vs by 2, and this is 0. Okay. Similarly, AB, just you subtract it, An minus Bn, we will get AB minus Vs, and BC Vs by 2, and Ca Vs by 2. Mode 5, 4, 5. So this is 4, so A is connected to the negative, and 5. 5 means this one, C is connected to the positive. Okay. A is connected to the negative, and C is connected to the positive. Okay. So C is connected to the positive, A is connected to the negative, right? So here we will get Cn Vs by 2, okay, and An will be minus Vs by 2, Bn will be 0, okay. Cn Vs by 2. We can find out AB minus Vs by 2, BC minus Vs by 2, Ca minus, plus Vs. Okay. So the last mode, 5, 6. So 5, C is connected to positive, 6, B is connected to negative. Okay. C is connected to the positive, B is connected to the negative. Okay. C is connected to positive, B is connected to negative. So here Cn will be Vs by 2, Bn will be minus Vs by 2, okay, and An will be 0, okay, An 0, Bn minus Vs by 2, Cn Vs by 2, AB, BC and Ca. Simply we have to just make some change here. What we have to do? We have to subtract An minus Bn for AB, and for BC, Bn minus Cn, and for Ca, Cn minus An. Okay. So like 180 mode, we will do the table. Okay. So we will write the An, Bn, Cn, all the phase voltage together and line voltage together. For all modes, what is the value of An? Vs by 2, Vs by 2 0, minus Vs by 2, minus Vs by 2 0. So it will help us to draw the waveform. Okay. So let us draw the waveform now. Okay. So what is An? Vs by 2, Vs by 2, then 0, then minus Vs by 2, minus Vs by 2 and 0. Okay. So this is VAN, Vs by 2 and this is minus Vs by 2. Okay. This is mode 1, mode 2, mode 3, mode 4, mode 5 and mode 6. Okay. What is Bn? First it is minus Vs by 2, then 0, then Vs by 2, Vs by 2, 0, that's minus Vs by 2. Okay. Similarly, we can go for Cn, 0, minus Vs by 2, this is minus Vs by 2, then this is 0 plus Vs by 2 plus Vs by 2. Okay. What is AB? What is the value of AB? In mode 1, Vs, then Vs by 2, minus Vs by 2, minus Vs, minus Vs by 2, then Vs by 2. Okay. So this is my Vs and this is Vs by 2. Okay. Similarly, BC, minus Vs, plus Vs, plus Vs, no sorry, minus Vs by 2, minus plus Vs by 2, this is Vs, then this is plus Vs by 2, this is minus Vs by 2, this is minus Vs. Okay. Similarly, we can draw for CA. Okay. Minus Vs by 2, Vs, minus Vs by 2, then what is this? Plus Vs by 2, plus Vs, plus Vs by 2. Okay. So this is all about the phase and line voltage. We can also do the similar kind of calculation as we have done in 180-degree mode. Okay. So this is the Fourier expression for the line voltages and this is for phase voltages. Okay. From there we can find out the fundamental component of line voltage, okay, and phase voltage as well. So this is the fundamental component of phase voltage. It's found to be 38.98, means near about 39% of input supply. Okay. The 39% of input supply, you will get the fundamental component. Okay. RMS value of phase voltage, okay, 40.82, okay, percentage. Then RMS of line, fundamental value of line, 67%, you will get fundamental component, and line voltage will be 70% of the input supply. Okay. So thank you for your attention. Have a nice day.